Okay, I've had many of you tell me, Mr. Roberts, I really see the power of this technique and I want to get good at it, but I don't understand it. So let's take a look at this closely. It stems from the fact that I can destroy fractions by multiplying um, across by denominators. So, for example, if let's look at let's not look at the check. Let's look maybe at a concrete example. If I have two thirds, and then I'll say plus 5 equals 2x. Okay, this is pretty straightforward. You can see that I just have the one fraction and it's not that intimidating. If I was to choose to multiply both sides of this equation by the number 3, everything would get a factor of 3. This term would get a 3, this term's going to get a factor of 3, and this term's going to get a factor of 3. It's very important that I train myself to see that I am indeed giving every single one of those a factor of 3. So as I push that factor of 3 too, this numerator becomes 2 times 3 over 3. You can see this particular fraction just got its number 3. The next thing I've got is this plus 5, but I need to multiply by 3. And then on the other side I've got equals, I'll just put the 3 in front, 3 times 2 times x. So if we look at it, I'll highlight these in yellow. This got a 3, this got a 3, and this got a 3. Every single one of those terms got a factor of 3 exactly the way I said it would. Now, the reason why I pushed through the 3 was because this had a denominator of 3, and I want you to look at what it's done for us now. We now have this giant 1, right? So because 2 times 3 is 6, and 6 divided by 3 is 2 again, right? I can just look at it and say this has to be the number 2. This changes, it's now 15, and this is now 6 times x. Okay, so this is the technique, right? Pushing the factor through that will destroy all of the fractions. Now let's go back to our problem. Here it is, and if I look at it closely, my denominator has a factor of 3, and it has a factor of x. And they're repeated, right? This one particular denominator has a factor of both 3 and x. Well, looking at that, that's enough. And I know already what I'm going to hit every single term with in order to destroy the fractions. Each one of these is going to get a factor of 3x. And if it's helpful for you, you might even consider writing it as 3x over 1, right? I'm pushing through a 3x on both sides, which is just 3x over 1. Now, on the left-hand side, right, 3x I have to multiply times 4. 3x I have to multiply times negative 2/3. On the right-hand side, I've got 2 over x, and I'm going to multiply that by 3x. And then I've got 14 over 3x, and I'm going to multiply that by 3x. Now, when I do this, right, this is what it becomes. 4 times 3x is 12x. The next thing, it's subtraction. I've got 3x times 2 divided by 3. That's 2x. Look at it. Think about that. Concentrate, right? That is becomes 2x. Notice it doesn't have a fraction anymore. On the right hand side, 2 over x, I'm going to multiply that by 3x. When I do that, that becomes the number 6. And then finally, when I take the, look at this, if that's confusing at all slightly, please focus on that, right? And you can write it all out. I've got a 2 times a 3 times an x over an x. These form a giant 1, and I'm left with 2 times 3, which is the number 6 that I have right here. Final thing that I've got there is I'm going to push this 3x into the 14 over 3x, and that becomes plus 14. Now, on my right-hand side, this is nice. It becomes the number 20. On the left-hand side, 10x minus 2x becomes 10x, and if I divide both sides by 2, I get that, I'm sorry, divide both sides by 10, I get that x is 2. So that's my solution, I think, right? I'm always willing to, I always want to check it and verify that it's correct, but I believe that the correct answer is x equals 2. Now I'm going to come over here and check this, and I think I'll do it without the calculator this time. Um, so I believe that x is the number 2. So my question is, what's 4 minus 2/3? Well, actually, let's change that. So 4 is 12/3. That's the number 4. Minus 2/3, which is 10/3. So on the left-hand side, I've got 10/3. On the right-hand side, right, the big question is, are these equal? On the right-hand side, I've got 2 over 2. That's the number 1. Plus 14 over 2 times 3, which is 6. Okay. So I've got 1 plus 14 sixths. Well, this is 1 plus, let's see, 14 6 I can rewrite as, I'll divide both of those by 2. So it becomes 7/3. The number 1 is the same thing as 3/3, and 3/3 plus 7/3 is indeed 10/3. Now, you don't need to do this by hand, and I've never advocated it, but once in a while it's nice to just, refresh yourself and make sure, yeah, I still understand rational numbers. But you most certainly can plug that value too into the right hand side and evaluate the left hand side with your calculator and see that, yeah, it forces both sides to become 10/3. So x is 2 is clearly my solution, not because I think my writing is compelling, but because when I plug it in, that equation says 10/3 is the same thing as 10/3.